Okay, so this is a second example from your worksheet, grade 12 physics, looking at the three different types of forces problems. This is going to be force type 2, where we're hanging an object and the force of tension in the wires that supports the object breaks up into components. This question reads, a traffic light is to be hung, like in the diagram to the right. Cable being used will break if its tension reaches 1750 newtons. What is the largest mass that can be hung? So kind of a little more realistic problem. If you want to actually hang something and you know what force will break your cables, then you can limit the size of your object, again knowing what angles you're going to be making here. So the angle between the two wires is 130, so even before I do anything else, use our geometry, that's going to break up into 25 degrees on either side. One full line makes 180, 180 minus 130 is 50, 50 divided by 2 is 25. All right, so back to the question. We're looking for mass, and so our answer should be about 151 kilograms. If you're looking for mass, mass comes into play in force of gravity. That's been consistent since kind of grade 11. If we're working with force problems and you want mass, mass is going to come into play with force of gravity. The only other place mass could come in would be Newton's second law, force equals mass times acceleration, which really is the same thing as kind of calculating force of gravity. So if we want to try and find force of gravity, we need to be able to work with the different components that it's made by the tension in the cables. So each cable has an upward component Ty, and each cable has a left and right component Tx. We can calculate those Tx's, but we're not going to need them because they're independent or perpendicular to the force of gravity. So the two Ty's we're going to figure out, and then we can use that with our force of gravity. So trigonometry does the rest. Or I should say we start with trigonometry to figure out what our opposite sides are, our upward components of Ty, and then our net force in the y direction will solve the force of gravity, and then from there we can get the mass. So I'll summarize that here as we try and figure out our components. The sine of the angle, just looking at the geometry, is the opposite component over the tension in the cable. Tension in the cable, remember, is going to reach a maximum of 1750, and that's in each cable. Well, our Ty, just rearranging, is our magnitude sine of theta, magnitude 1750 newtons, sine of 25 degrees. It's very important that you figured out which angle you're going to use there. Okay? When you make your triangle, you've got to use the correct angle, and that's the 25 degrees one. And that'll calculate to be a value of 740 newtons. So each Ty on either side works out to be 740 newtons. Remember, that's the maximum component of weight that each cable can support. So let's go into our net force now in the y direction equals the sum of the forces. I can do better than that. There we go. It's much better. In a particular direction, so this time it's the y direction. So F net in the y direction equals the force of gravity added to the two force of tension. So I'll write them individually, the y components. Net force is 0. We're assuming this mass is hung, it's not moving anywhere. Force of gravity is what we're trying to figure out. And each of those cables supports 740 newtons. So that means the full weight would be 740 plus 740. And it's going to come out to be negative, meaning it's downward, and there's nothing wrong with that. So rearranging and just kind of rounding a little bit, 1480 negative 1480 newtons is the force of gravity. Negative meaning it's downward. Good, that works. I like it. And now to figure out mass, well, force of gravity is mass times the acceleration of gravity. So I'll stick with the negatives to be consistent with our direction. Negative 1480 equals mass times negative 8.1. Let's divide both sides by negative 9.81, and we're going to get a mass of 151. So that rounds up to 151. Mass should always come out to be positive. It's not a vector, it is a scalar quantity, so just a little reminder on that. So, quick summary on doing this problem. If we're asked for mass, we take the the value of the tension in each cable, use our trigonometry to break it up into components. The two upward components have to add with the force of gravity to give you 0. And once you have the force of gravity equals mass times the acceleration of gravity, and then the rest, as they say, is that.